In this video, we're going to look at 4 different problems that involve SUVAT equations in one dimension. The first question is here. Pause the video and try this question now. Part I is asking us for the braking time. So what information have we been given? A good strategy is to always list the information. So we have the initial speed, we have the final speed, which is 0 because it says it's come to a stop, and we've been given the distance. So if we knew what the average speed was, we could work out the time really easily by using distance over time. So we can work out the average speed by doing u plus v over 2. So 50 plus 0 over 2 is 25 meters per second. This is the average speed. So now we can use speed is distance over time. This is not helpful because our symbols are different. Let's use the average equals the displacement over time, so speed is distance over time. So time is going to be S over V average, which is going to be 790 over 25, which will equal 32 seconds. In part II, we're asked to find the deceleration of the aircraft. So there's 2 ways we could do this. We've been given u, v, and s, so we could use v squared minus u squared is 2as. That would be absolutely fine. Or I could use my answer to part 1 and say that v is u plus at. There's no right or wrong way to do this. I'm going to use this one just because it doesn't involve squares, so it's slightly quicker, but there's nothing wrong with using the other one. You'll get exactly the same answer. So 50 minus the final velocity is 0, the initial velocity is 0, the final velocity is 0, the initial velocity is 50, divided by the time, which is 32 seconds. So we've got minus 50 divided by 32, which is minus 1.6 meters per second squared. What does the minus sign represent? And this just represents the fact that it's slowing down. And usually we can just ignore that on the exam and they don't mind at all. Question 2. Pause the video now and try this question. Part I asks us to work out the acceleration. So let's again list our variables. So the initial velocity is 3 meters per second. The final velocity is 18 meters per second. And the time is 5 seconds. And we're being asked to work out the acceleration. So again, the easiest one to use is v is u plus at. Or a is v minus u over t, changing velocity over time. So 18 minus 3 over 5. So that's the same as 15 over 5. I don't even need a calculator for that, do I? So 15 over 5 is 3 meters per second squared. Part II, the distance it travels in this time. So now I'm being asked for the distance and I have all the other variables. So I could use a number of equations here. I could use v squared minus u squared is 2as, or I could use s is ut plus half at squared. I'm going to use this one just because it doesn't involve any rearrangement at all, but there's nothing wrong with using this equation. So s is our initial velocity 3 times by the time, which is 5 seconds, plus the distance it travels while it's accelerating, half times 3 times 5 squared. So that's 15 plus 1.5 times by 25 is equal to 53 meters. I'm going to give my answer to 2 significant figures because that's what I've been given in the question. Question 3. Pause the video now and try this question. How fast is it traveling after 4 seconds? So let's again list our variables. T is 4 seconds. It's dropped from a height, so our initial velocity is 0, and our final velocity is what we're trying to work out. What else do we know? Well, it's being dropped, which means it's accelerating due to gravity. So our gravity is 9.8 meters per second squared. Every second it will get faster by 9.8 meters. So I can again use V equals U plus AT. 0 plus 9.8 times by 4, which gives us 39 meters per second. Just per second. Part II, the distance it travels between 2 seconds and 3 seconds. So the distance, I'm going to use displacement, is ut plus half at squared. And we want to know the distance it travels between 2 seconds and 3 seconds. So a lot of people will instinctively write this down. 0, because u is 0, plus half times 9.8 times by 3 minus 2 squared. But this is wrong. The reason that this is wrong is because 3 minus 2 squared is not the same as 3 squared minus 2 squared. And we only want the distance it travels between 2 and 3. So what we actually need to do is work out the distance it travels after 3 seconds and subtract the distance it traveled in the first 2 seconds. So what we need to say is that S is ut, which is obviously 0. So it's going to be half times 9.8 times by 3 squared minus, again, this is 0, half times 9.8 times by 2 squared. Now we can solve this equation. So 0.5 times 9.8 times, and then I can do 3 squared minus 2 squared this way, and I get 25 meters. Question 4 is here. Pause the video now and try this question. So again, let's list our variables. Our initial velocity is 12 meters per second upwards. Our deceleration is minus 9.8 meters per second squared, because we have our stone or our ball. It's traveling upwards, and gravity is of course acting this way to slow it down. Our velocity, well, if it's we're trying to find its maximum height, then its velocity at the top will be 0. And displacement is what we're trying to find. So the equation that links these two together is v squared minus u squared is 2as, or rearranging for s, v squared minus u squared over 2a. Now we can plug in our numbers. 0 squared minus 12 squared over 9.8. So minus 12 squared over minus 9.8 squared. And you'll see the minus signs cancel. So it's not a problem that we've chosen negative for gravity. So that's 14, I'm going to round that up, 15 meters. If you hadn't chosen gravity as negative, then you'd get a negative answer here, and you'd obviously have to make the correction there. But this is the correct method.